Okay. So, we'll start with the first topic. What is a random signal? A random signal is one in which whose amplitude at a certain instant of a time or any instant of a time cannot be determined. For example, a noise is a random signal. That is, a signal which varies randomly is known as a random signal. So, that is the definition for a random signal. That is, its instantaneous value is not important, because even if we take an instantaneous value, it is random, right? So, there is no use taking it, or not we can't say that no use taking it, but it is not deterministic. For example, if you take a sine wave, if you take the instantaneous value, we know at a certain angle or at a certain time what will be the value of this, but in case of a random signal, that is not possible. Okay. And another thing to be noted about a noise is that noise can be white noise or colored noise. White noise is one in which whose frequency spectrum extends from minus infinity to plus infinity, and other noises of frequency spectrum is band limited. Why this white noise is whose frequency spectrum is extending from minus infinity to plus infinity means that it affects all the frequencies. Okay. Regardless of what high frequency or low frequency, this white noise will be affecting all the frequencies, while in the case of other band limited noises, that is red noise, green noise, etc., like that, it will be affecting a certain range of frequencies only. Okay. So, that is to be noted about white noise and other color noise. And this you should have already studied in your plus 2, that is 12th standard, that is P of A given A comma B, that is a joint probability. A comma B is equal to P of A given B into P of B. P of A given B is the conditional probability. This is known as the conditional probability, that is B already occurred, and then what is the probability that A occurs, okay, or P of B given A into P of A. So, now this is known as a discrete probability. Okay. This is about a certain point, but when it comes to continuous probability, there should be a range. So, we are going to deal with what is known as continuous probability. So, there will be a range of values that this x can take. For example, for P of A, for example, if I toss a die, okay, let A be the event that an even number occurs. So, this is a discrete probability. Okay, even number occurs is a discrete probability, it will have a certain value. Okay, but when it comes to continuous probability, this will be a range of values that this x can have. So, that is the thinking about continuous probability, that is P of x will be equal to P of x less than or equal to x. Okay, x, this variable can have, this is a variable. In case of this one, A is not a variable here, okay, but here it is a variable which can have a value less than or equal to x. Okay, this is a definition of a continuous probability. And then comes our random time function. So, this is an example of a random time function. This can be anything, anything which is random can be an example of a random time function whose value at any instant cannot be predicted. This is known as a random time function. So, in the figure shown, the x of t is a random time function. And what is a random process? A family of these kind of x of t is known as a random process. A family of a lot of random functions is known as a random process. Okay. So, what is an ensemble? So, what when it comes to random process, a family of x of t in which each of them is a random function, that is a random process. What is when it comes to ensemble, ensembles are random process, but it will have a probability attached to it too. Okay. So, x of t, set of x of t is known as, set of x of t means random functions. The family of a random functions is known as random process. But when it comes to ensemble, what happens is x of t with its probability will be attached to it. Okay. So, that is the difference between ensemble and random process. Okay. So, ensemble is actually a random process, but here each member has a number which is the probability of occurrence of that particular x of t. Okay. That is the difference between ensemble and random process. Okay. Now, let us take a function x of t. Okay. I have taken a random function, random time function x of t, and I am going to take a value at t is equal to t1. Let the instantaneous value be x1. Okay. Now, as you can see, the time is frozen here. Okay. We are taking the value t1. Now, let us consider that this family has 100 members, 100 random functions like x of t. Okay, this is a random process who has 100 random functions like x of t, not identical to x of t, but like x of t. Okay. So, what happens is that in each x of t, that is one is x1 of t, x2 of t, x3 of t, etc. up to x100 of t. Okay. From each x of t, we are going to take this t1 instant and finding out our x1. Okay, at each functions x of t. Okay. So, as you can see, in x1 of t, this variable x1 will have a certain value. In x2 of t, at time instant t1, this x1 will not have the value as similar to x1 of t, right. So, this is now not a function of time, because time is frozen here. We are taking t1 at every all the functions, we are taking all the functions and taking the value at time t1. That means time is frozen here. What is going to change? What is the variable here? Our x1 is changing from function to function. x1 will have a certain value for x1 of t, x1 will have a certain value for x2 of t. Okay, this one is changing. So, that is it, and the variation of x1 over the ensemble cannot be predicted. So, what is a random variable here? Our x1 is the random variable here. So, you got what is a random time function, what is random process, and what is random variable. Okay, this is not a function of time, it is varying. Okay, this variable cannot be predicted along the ensemble. So, it is known as a random variable. So, which is not a function of time. Okay. We do not know what will its value will be with regards to each function. Okay. And now, some properties, that is our p of x, that is our continuous continuous probability is equal to p of x less than or equal to x, that is its random variable x that I have mentioned earlier, right, x1. Instead of that, we have x here. So, what is the probability that this random variable x can have value less than or equal to a range, that is x. Okay. And similarly, a continuous probability will have the same property like discrete probability, that is its range will be, minimum value will be 0 and maximum value will be 1, and p dash of x will always be greater than or equal to 0. Please keep this in mind. The derivation of continuous time probability will always be greater than or equal to 0. Okay, it can never be negative. Okay. And p of minus infinity is equal to 0 and p of infinity is equal to 1. Okay. These kind of things you should not. And if it is p of x1 less than or equal to x less than or equal to x2, that is our random variable x is ranging from x1 to x2, then the probability will be equal to p of x2 minus p of x1. Okay. And p of x is known as the capital P of x. Please keep this in mind. Capital P of x is known as probability distribution function, because P of x versus x is a continuous curve. Okay. And it is denoted by PDF, capital PDF. Okay. So, can be of a different types, but whatever the types may be, the slope should always be non-negative. I have given the equation like this, right. The slope, what is the slope? Slope is known as the differentiation, right, should always be greater than or equal to 0. So, it cannot be non-negative at any instant of time. Okay. Slope is always non-negative. And what is this derivation of a continuous time probability known as, or our PDF? If I am, please write probability distribution function in caps. Okay, d by dx of a PDF will give us capital P of x. Okay, capital P dash of x, which is equal to small p of x. So, this is known as probability density function. Okay, probability density function, this is denoted by small PDF. Okay, small PDF for probability density function and caps for probability distribution function. Probability density function is nothing but the differentiation or the derivative of probability distribution function. Okay, and what is P dash of x? P dash of x, the definition of derivation is P of x plus dx minus P of x divided by dx. I am cross multiplying it, we will get P of x into dx is equal to P of x plus dx minus P of x. Earlier we have told that P of x1 less than or equal to x less than or equal to x2 equal to P of x2 minus P of x1. Oh, here instead of that we have x plus dx minus P of x. So, that means our x2 is x plus dx and x1 is x, right. So, instead of that I can write this one as P of x, that is varying between x plus dx and x. So, that is what is written here. Okay. So, the P of x into dx, that is our probability density function into d of x, is the probability distribution between x and x plus dx. So, this is known as probability element, which indicate the probability that the random variable x lies between x and x plus dx. Okay, you are getting what I am saying. P of x into dx, it is known as probability element because it is being multiplied by dx of say dx is a small value. So, P of x into dx is the probability that our random variable lies in between x and dx. Okay. So, here also P of x should be greater than or equal to 0, no upper limit can extend up to infinity, and another very important is the integration, total integration or the area under our P of x will always be equal to 1. Okay. Minus infinity to infinity, P of x into dx will be equal to 1. This is very important while doing problems. Okay, we will always be using this while doing problems. That is integral minus infinity to infinity P of x dx is equal to 1. So, this is to be noted here, and to find out a probability density function, probability distribution function from probability density function. What is probability density function? Is d by dx of probability distribution function, right. So, to find out probability density distribution function from probability density function, what we are going to do is we are going to integrate it, right, minus infinity to x P of x into dx. Okay. So, that is what is written here, that is all. So, please see the upper limit is x and lower limit is minus infinity. Okay. And we will come to Gaussian later. Relay is the probability density function of a relay is x divided by eta square e raised to minus x square divided by 2 eta square, and exponential the probability density function is alpha into e raised to minus alpha x, and uniform density function is will have 1, that is probability is equal to 1 within a range of x1 and x2. Okay. And we will come to that later. The mean value and moments is very important. So, we are going to consider a random time function. What is a set of random time function known as a random process, and a set of a random time function with their individual probability is known as ensemble. So, we are going to find out our ensemble average. So, that is average value of a random variable over the complete ensemble, that is our x, right, x1, right. We have studied about x1 previously, that is the average value of x1 over the complete ensemble is known as the ensemble average. Okay. So, that is equal to x bar, which is equal to integral minus infinity to infinity x into p of x dx. This is very important formula. Whenever you are asked to find out the ensemble average, what you have to do is please multiply x into probability density function and then integrate it minus infinity to infinity. Okay. So, what about a function f of x? If it is a function of x, then also f of x into p of x dx, integral minus infinity to infinity. This is known as ensemble average or expected value of x. Okay. So, since it is expected value, we are denoting it as e of x, which is equal to x bar. Okay. And now we will go to central moment. Central moment is equal to Cm of n is equal to expected value of x minus x bar the whole raised to n. Okay. Or I can write expected value, instead of expected value, e of x is known as x bar, right. So, e of x minus x bar the whole raised to n will be x minus x bar the whole raised to n the whole bar. Okay. So, instead of that I have written like that. So, to find out x minus x bar the whole raised to n, I have found given the equation that minus infinity to infinity x minus x bar the whole raised to n p of x dx. So, that is what is written here. And when n is equal to 1, what happens when n is equal to 1? N is equal to 1 means x minus x bar only, okay, raised to 1. So, we will get what is this? This is equal to x bar only and this is equal to x bar. So, it will be 0. So, what is happen when n is equal to 2? We are going to expand it. We will get x square minus 2x into x bar plus x square into p of x, and rearranging it, what is this? X square into p of x. This means our f of x now is this one. That means this, the complete one is the mean of f of x. Okay, that is x square the whole bar minus 2x into this one is x bar, we know that mx into x bar plus x1 square. So, the answer we get is x square bar minus x bar the whole square. This is known as the variance. Okay, this is a very important formula for variance. So, for mean the formula is x into f of x, sorry, x into p of x dx. For variance the formula is x square bar minus x bar the whole square. This is a very important formula. Okay. And now we are going to look at the uniform distribution, that is from a to b it have a value of a, and we know that the total probability, that is minus infinity to infinity p of x is equal to 1, and from here we get a is equal to 1 divided by b minus a, and p of x have value a from a to b. Okay. And to find out x bar, what is the formula for to find out x bar? F of x into, sorry, p of x into x dx, right. So, we will get this, and this is an important formula for a uniform distribution. The mean is a plus b by 2, and the variance is, where is it? Variance, okay. Variance is b minus a the whole square divided by 12. These are two important formulas for a uniform distribution. The mean is a plus b divided by 2, and the variance is b minus a the whole square divided by 12. Okay. And what is the standard deviation? Standard deviation is nothing but the root of variance, so that is b minus a divided by root 12. Okay. And Gaussian distribution, we are coming to Gaussian distribution. Gaussian, many of the physical phenomena can be modeled using Gaussian function. We always hear about a Gaussian function while doing problems and usually while studying. So, this is because many of the physical phenomena can be modeled by using Gaussian function. It is a very important topic, and the probability distribution of a Gaussian function is 1 divided by root 2 sigma, sorry, root 2 pi sigma e raised to minus x bar the whole square divided by 2 sigma square, and that is the probability density function for a Gaussian variable. I once again repeat, 1 divided by root 2 pi sigma e raised to minus x bar the whole square divided by 2 sigma square, and the features are approximation equal to physical process, easy to handle, analytical, and if it is a joint one, we wrote this like a p of x, right, and if it is having two variables, that is p of x comma y, it becomes 1 divided by p of x comma y, it becomes 1 divided by root 2 pi sigma x into 1 divided by root 2 pi sigma y into e raised to minus x bar the whole square divided by 2 sigma x square into e raised to minus y bar the whole square divided by 2 sigma y square. So, after solving we get a root 2 and a root 2, we will get 2 pi sigma x into sigma y e raised to minus x bar the whole square by 2 sigma x square plus y bar the whole square divided by 2 sigma y square. Okay. So, that is what is written here. So, please keep this in mind, this is a very important formula. And so this is not the case for all other distribution, where both the probability and the joint probability are the same, because it is almost the same, right, but only Gaussian have this property. So, that is a property of a Gaussian function. Gaussian random process can be distributed completely by described completely by its first and second moment x bar and x bar square. And now coming to stationary and non-stationary process, that is, if there are we are taking a function x of t and the time t1 is taken and time t2 is taken, and the probability of x1, that is x of t1, and the probability of x of t2 are the same. This is a probability density function for a single random variable. So, these are the same, then it is known as stationary process, and that is value of x of t at a time instant t1, the probability, that means probability, okay, the probability of occurrence of x1 is equal to the probability of occurrence of x2, then it is known as a stationary process. If it is not, it is known as a non-stationary process. Okay. If there are three, we have considered one random variable at a time, right. So, if we are considering two random variables at a time, p of x1 and x2, and at a time instant t1 and t2, p of x1 dash and x2 dash at time instant t1 dash and t2 dash, whether this must be satisfied. Okay, t2 dash minus t1 dash should be equal to t2 minus t1, that is a time interval. The PDF only depends on the time interval, but not on the origin of time. Okay, then it is known as a stationary random process. Okay. If there are three variables, that is x1, x2, x3, and we are just writing the time interval. Okay, for now we are just writing the time interval, that is t3 minus t2 and t2 minus t1, and here also t3 dash minus t2 dash minus t1. What should be the condition? t2 dash minus t1 dash should be equal to t2 minus t1. Again, t3 dash minus t2 dash should be equal to t3 minus t2. This is also a stationary random process. Okay, and now ergodic and non-ergodic process. Ergodic function is a stationary random process in which almost all members of the ensemble have the same statistical characteristics as that of the ensemble. Okay. So, all members of the ensemble will have the same statistical characteristics as that of the ensemble, that is known as ergodic process. Okay. So, in case of ensemble average, in this case ensemble and in ergodic process, this is a very important property. Ergodic process ensemble average will be equal to time average. So, how to find out the ensemble average? We already know that to find out the ensemble average, x raised to n p of x dx. To find out the time average, the formula is limit t tends to infinity 1 divided by 2t minus t to t x t or raised to n dt. Okay, that is the time average. So, ensemble average is equal to time average in case of ergodic process. Once again repeating, ergodic process is a type of stationary random process in which almost all of the members of the ensemble will have the same statistical characteristic. In this kind of ergodic random process, what happens is ensemble average will be equal to time average. Okay. And now here comes a very important topic, that is correlation function. So, if they are coming from the same random process, it is known as autocorrelation function, and if two random variables come from two different random processes, it is known as cross correlation. Okay. Rx of a t1 comma t2, that are two time instances at a process, the same process. Okay, we are considering autocorrelation now, so we are using the same process. So t1 comma t2, that will be equal to Rx of t1 plus t comma t2 plus t, because this is given that it is a stationary process, then it is a stationary process, it will only depend upon the time interval. Okay, here the time interval is capital T. If capital T is equal to minus T1, what happens? Rx of T1 minus T1, T2 minus T1, because we have to take the time interval over here. Okay. So now Rx of 0, it will be given like Rx of 0 comma T2 minus T1. So the autocorrelation function of a stationary random process should be a function of time interval only, because it is a stationary random process. A stationary random process, we have already studied that in a stationary random process it depends upon the time interval only. Okay, and it should not depend upon the origin of a time. Okay, so that is it, and that is a PDF, it does not depend upon it. In the previous section we have studied that in a stationary random process the PDF does not depend upon the origin of a time, it depends only upon the time interval in case of a stationary random process. Okay, so Rx of a tau is equal to expected value of x of t into x of a t plus tau. So this is an important formula, that is Rx of it. The autocorrelation can be found out by taking the mean of x of t and a shifted version of x of mean of a product of x of t and a shifted version of x of t. Okay, it can be shifted to left, either left or right. So it can be x of t into x of t minus tau as well. Okay, no change in that, and Rx of a tau is equal to Rx of a minus tau. This is a very important property of an autocorrelation function. This is known as ensemble autocorrelation. Okay, there is another one known as time autocorrelation function too, we will come to that. So this is known as ensemble autocorrelation, and then what you have to know is autocorrelation function is an even function, and that is Rx of a tau is equal to Rx of a minus tau. Okay, only. So there won't be much change in autocorrelation function even if it is reversed. Okay, time reversed, sorry, if it is shifting to the left side or the right side, that means minus tau or plus tau, it will be the same. Okay, so it is also ergodic, then it can be calculated in the time domain also. I have already mentioned earlier that if it is ergodic, the time ensemble average will be equal to time average. Okay, if it is ergodic. So we are going to find out the time autocorrelation also. The time autocorrelation function, the formula is limit t tends to infinity 1 divided by 2 t integral minus t to t x of t a t plus tau dt. Okay, dt. Please do not write like a d tau, that is used in convolution. Okay, here it is x of t plus tau dt. Okay, and since it is ergodic, Rx of tau will be equal to t. This is just to represent that it is time autocorrelation. Okay, not much significance is there for this t, it is just to represent that it is a time autocorrelation, that is t Rx of tau, that will both of them will be the same. This is known as time autocorrelation function. Okay, and when tau is equal to 0, what happens when tau is equal to 0? It will be x of t into x of t. Okay, what is x of t into x of t? X square of t, and if I am taking the mean of it, then it is known as x square t, right, x square t the whole bar. If this is zero mean process means x bar will be equal to 0. This one is x square the whole bar. We know that the variance is equal to x square bar minus x bar the whole square, which is equal to 0, which is given that it is a zero mean process. So in this kind of situation, then x bar square will be equal to sigma x square. Okay, so the autocorrelation function Rx of 0 will give us the mean square. Okay, this is a square and we are taking its mean, so it is known as a mean square. Okay, if a question is asked like to find out the mean square of a certain thing or certain function or something like that, please find out the autocorrelation of that with tau is equal to 0. Okay, that is the only thing you have to. And if tau not equal to 0, what happens if tau not equal to 0? Rs of a tau gives us the measure. What is this autocorrelation? Okay, we have to know what is this autocorrelation. That means the measure of a similarity between, I said that the x of t and its shifted version are multiplied, that is x of tau, x of t and its shifted version when t is equal to t plus tau. Because it is a random variable, x of t and x of t plus tau will be different, or in other words, we are measuring how much of x of t is retained in the waveform after the interval tau. Okay, now consider a zero mean stationary process. Okay, the process is given by this: y of t is equal to x of t minus rho into x of t plus tau. Choose rho such that sigma y square equal to y bar square is minimized. Okay, so it is minimized. This is a zero mean function, so it will be our y square bar. It is actually y square bar. Okay, y square bar, this is not here. Okay, this is not here. Y square bar will be equal to sigma y square, and we have to choose rho in such a way that sigma y square will be equal to 0. So, what is sigma y square? Sigma y square is equal to y square the whole bar. So, y square the whole bar is nothing but expected value of y square, which is equal to, what is y square? X square t plus rho square x square t plus tau minus 2 into rho x of t into x of t plus tau. Okay, from we can write y square bar. Okay, y square bar equal to expected value. I am taking it inside. We will get expected value of x square of t plus rho square into expected value of x square into t plus tau minus 2 into rho of e of x of t into x of t plus tau. So, this one is actually equal to x square the whole bar. Okay, this one is again it is x square the whole bar. Okay, and this one is, have you seen this? This is the definition of Rx of tau, the autocorrelation, right? So, we have written that, and now y square equal to x square bar plus rho square x square minus 2 into rho Rx of tau, and taking, we know that it is a zero mean process, then means sigma x square, this is equal to sigma x square. So, sigma x square is taken outside, we will get 1 plus rho square minus 2 rho into Rx of tau. And if I am taking, it is given here that choose rho in such a way that it is minimized. So, we are using maxima and a minima here, that means their derivation should be equal to 0. Okay, that means sigma rho y square divided by sorry, dou by dou rho of sigma y square should be equal to 0. And if I am taking the derivation, we get rho is equal to Rx of tau divided by sigma x square. This is a very important formula, please keep this in mind. Rx of a tau divided by sigma x square, this is for correlation coefficient. This is known as correlation coefficient or normalized correlation coefficient. I repeat, rho is equal to Rx of a tau divided by sigma x square. This is for autocorrelation. For cross correlation, it will be different. I will be sharing that. So, what is the range of values for rho? Rho can have values between -1 to +1. Okay. So, when it is +1, what happens is it is perfectly correlated, and if it is 0, completely uncorrelated, and if it is -1, it is x of t and a minus of x of t plus tau are perfectly correlated. Okay, and the maximum value of correlation, autocorrelation will be when tau is equal to 0. So, Rx, this is also an important property that should be remembered, that is Rx of 0, that is when tau is equal to 0 is a maximum value, and x of t has a DC component, Rx of tau will also have a DC component. If x of t has a DC component, Rx of tau will also have a DC component, and when time t tends to infinity, Rx of tau will be equal to 0, or tau tends to infinity, I am sorry, it is tau. Okay, tau tends to infinity, Rx of tau will be tending to 0, because as a tau tends to infinity, that means that we are finding out the similarity between x of t and a signal or a shifted version of x of t, or the value of x of t at an instant of a time which is very much further apart from our x of t. So, there can't be much similarity between, that is how much x of t is retained in this x of t plus tau, where tau is almost up to infinity. We cannot it must be equal to 0, it must be tending to 0. Okay, please keep this in mind. And now we will see what is cross correlation and their properties. So, we said that if it is from the same process, it is known as autocorrelation. If it is from two different processes, it is known as cross correlation. So, I am taking x1, that is x of t1, and y2, that is x of t1 plus, sorry, y of t1 plus, these two are two different processes, okay, are jointly stationary, and p of x1 comma y2 are independent of t0. Okay, and what is the formula for Rx of a tau? Rx of a tau is equal to expected value of x of t into y of t plus tau. Okay, and we can find out using we know that E of x of, we find it out by minus infinity to infinity x into p of x dx. So, instead of that, it is a joined one. So, we will write it like this: p of x comma y dx dy, instead of the x of t, y of t plus tau, p of x comma y dx dy, and integral is from minus infinity to infinity. What is r y x of tau? R y x of tau means y of t comes first, and then x of t is shifted version, that is y of t into x of t plus tau, p of y comma x dy dx. Okay, now please don't think that r x y of tau is equal to r y x of tau. R x y of tau is not equal to r y x of tau, because it is these two are different processes, and also they are random. Please keep this in mind. So, x of t will not be the same as y of t, okay, and vice versa, and x of y of t plus 1 will not be the same. We cannot predict what is the value at a certain instant of a time. That is why it is known as a random process, right, random function. Okay, so we cannot write r x y of a tau is equal to r y x of a tau. It may or may not be, and most of the we cannot say that r y x y of tau is equal to r y x of tau. So, it is safe to write like r x y of tau is not equal to r y x of tau. And when it comes to the time cross correlation, it will be like this: limit t tends to infinity, 1 divided by 2t minus infinity to infinity x of t y of t plus tau d tau. Okay, and y x, what is comes y x of a tau? Y x of tau also integral minus infinity to infinity, sorry, limit t tends to infinity, 1 divided by 2t minus infinity minus t to t y of t x of t plus tau d tau. Sorry, it is dt. Okay, and if it is ergodic, then both of them will be the same. Okay, time autocorrelation function and ensemble time cross correlation and ensemble cross correlation, and our properties are r x y of 0 equal to r y x of 0, no particular physical significance. So, we can use it here, r x y of 0, that means this won't be there, r y x of 0 also, this won't be there. So, that will be equal to so what is r x y of tau? R x y of tau is equal to E of x of t y of t plus tau, or I can write like E of x of t minus tau y of t. Okay, the only thing that should be here is the time interval between these two. Okay, so what is r y x of tau? E of y of t into x of t plus tau, or yx of minus tau we will get E of y of t into E of t minus tau, x of t minus tau, right. So, this one is equal to this one. So, I can write like r xy of tau is equal to r yx of minus tau. So, that is why this property came into being. Okay, r xy of a tau is equal to r yx of minus tau. Okay, they are jointly stationary. That means they both depend upon the same time interval. Okay, and r x of tau was maximum, that is our autocorrelation was maximum and tau is equal to 0. R x y of a tau cross correlation is not necessarily maximum at tau is equal to 0, but it has one other property, like it will have a maximum value that is equal to less than, that is power spectral density of an autocorrelation function should always be positive. To find out the power spectral density, first of all find out the autocorrelation function and then find out this Fourier transform, you will get the power spectral density of that particular function. Okay, power spectral density is denoted by Sx of f. Okay, so power spectral density and autocorrelation function are Fourier transform pairs. Okay, and or if you want to find out the power spectral density of a certain function, just find out the Fourier transform and then take its modulus and then square it. So, that is a power spectral density. So, PSD of an autocorrelation function should always be positive. So, a rectangular function cannot be an autocorrelation function, because in the frequency domain it is sinc function, which is non-negative at certain instant, right. This is like this, right, a sinc function, it is negative. So, that is it. So, a rectangular function cannot be an autocorrelation function, and even though it is an even function. Okay, because in the frequency domain it is a sinc function, and power spectral density is the spectrum or the distribution of a power in the spectrum. Okay, that is known as power spectral density. And to find out if f of x, if it is a joint probability distribution function or probability density function, then f of x is equal to integral minus infinity to infinity f of x comma y dy. Okay, to find out x we have to set the variable dy, and if f of y is equal to minus infinity to infinity f of x comma y dx. And now comes to correlation coefficient, we have already derived it for autocorrelation, that is rho is equal to rx of a tau divided by sigma x square. But when it comes to, this is for autocorrelation, but when it comes to cross correlation, what is it, r x y of 0, here it is R12 which is equal to R x y of 0 divided by root of E1 into root of E2, that is energy of E1 for signal 1 into energy of signal 2. Okay, so that is a correlation coefficient. In case of a cross correlation, I repeat, R x y of 0 divided by E x root E x into root E y. So, that is the formula. And if two random variables are added, then the PDF will be convolved. Okay, for example, if x is equal to z is equal to x plus y, and x has a PDF of f of fx of x, and this has a PDF of fy of y, then z will have a PDF of fx of x convolution fy of y. Okay, so that is it. And we have already found out that Rx of 0, that is autocorrelation function, Rx of 0 is the mean of x square of t. We have already found it out, and sigma z square is equal to E of expected value of z minus mu z the whole square, where mu is the mean. Okay, ensemble average. Okay, z minus mu z the whole raised square, and it find out the expected value, then we will get the mean. And if z is equal to x plus y and mu z, the mean value of z will be equal to mu x plus mu y. Okay, the PDFs are convolved, but to find out the mean, add the individual means. Okay, and E y minus mu y, we will get E of y minus E of mu y. expected value of mu. This is equal to mu y and this is equal to mu y itself, which is equal to 0. That is why it is equal to 0. Okay. And two random variables x and y are uncorrelated if e of x y minus e of x into e of y equal to 0. That is, covariance should be equal to 0. So, covariance, to find out the covariance, the formula is e of x y minus e of x into e of y. Okay, uncorrelated when covariance is equal to 0. What is meant by covariance, I will be discussing that. And to find out the power from power spectral density, just take the area under it, because power spectral density is the distribution of a power with frequency over frequency. So, that is, if we take the area, we will get power only. Okay. Power, to find out the power from power spectral density, just integrate it from minus infinity to infinity with respect to frequency. Okay. And we have discussed the area, autocorrelation function and the power spectral density of Fourier transform pairs. So, this is very useful while doing problems. So, please keep this all this in mind. And our x of tau is equal to e of x of t into e of x of t plus tau, and e raised to minus pi t square Fourier transform is equal to e raised to minus pi f square, and if it is e raised to minus a t square, it is equal to root pi by a e raised to minus omega square divided by 4a, and if it is written in f format, then it is equal to root pi by a e raised to minus a square f square, sorry, it is pi square only. Okay, pi square f square divided by a. Okay. And PSD, to find out the PSD of g of t, first find out its Fourier transform, we will get g of f, and then find out its modulus and then square it. So, that is only and output PSD. This is a very important relationship if it is this is a system. Okay. We will say x and this is h of t, x of t, and this is y of t. So, this is output power spectral density is x y of f, say x y of f will be equal to x of f, that is the input power spectral density into the power spectral density of h of t. Okay, h of t's power spectral density is h of t, h of f the modulus square. Okay, e raised to minus alpha tau, the Fourier transform is 2 alpha divided by alpha square plus omega square, and if it is y of t is equal to x of t minus t minus tau, we have to find out the power spectral density, then we have to find out the individual power spectral density of x of t as well as the impulse response power spectral density. So, we have to write it in that way only. So, convolution, we know that y of t is equal to x of t convolution h of t only. So, we have to find out this x of t. So, we will always write it in terms of our delta, that is x of t minus x of a t minus tau can be written as x of t convolution x of delta of t minus delta of a t minus tau, because x of t convolution delta of a t minus t 0 is equal to x of t minus t 0. We know this property of a delta function. So, we are using it, then this becomes x of t, and we will be able to find out x y of f easily. Okay. And similarly, if it is x dash of t minus x of t also, we can write it as x of t convolution delta of dash of t minus delta of t. Okay. And then r x of a tau, and this is a very important relationship, the relationship between correlation and convolution. The r x of a tau is equal to x of tau convolution x of minus tau. Okay. Convolution x of a minus tau. So, that is the relationship between correlation and convolution. And this is also another important thing to be remembered while doing problems. It will be very easier, that is 1 divided by root 2 pi sigma square integral minus infinity to infinity e raised to minus x square divided by 2 sigma square into x square equal to sigma square. Okay. And if it is coming in this format, that is x cube into e raised to minus sigma x square dx, please substitute like this: d by dx of e raised to minus x square divided by 2 sigma square equal to minus x into e raised to minus x square divided by 2 sigma square divided by sigma square, and substitute that over here, then it will be easier to do. Okay. And another important thing is e raised to integral minus infinity to infinity e raised to minus x square is equal to root pi, integral 0 to infinity e raised to minus x square dx is equal to root pi divided by 2. That is also a very important relationship. And the other thing is we are going to use this probability. This is also from the important questions that I have written this short notes. Okay, that is P of m0 and P of m1. There are two messages m0 and m1, and it is received as r0 and r1, and if it is no noise is there, then m0 will be received as r0. That is the probability of getting r0 if m0 is sent is known as P of r0 given m0, and the probability of getting r1 if m1 is sent is P of r1 given m1. And if there is a because of a noise, if the message is tampered, then we will receive r0 instead of r1, and if m1 is sent, we actually should get m1, right? Sorry, r1 if m1 is sent, but instead of that we will get r0, and the probability of that is P of r0 given m1. And if we are receiving r1 instead of r0 when m0 is sent, then it is known as P of r1 given m0. Okay, and if r0 is received, for instance, if r0 is received, it can be that m1 was sent or m0 was sent. Okay, so to decide on which message to take, we will use this condition. If we choose m0, if P of r0 given m0 into P of m0 greater than P of r0 given m1 into P of m1. Okay, and if we will choose m1 if this one is greater than this one. Okay, and if r1 is received, what happens if r1 is received? We will have to choose m1. Theoretically, we have to choose m1, but if we will have to see if the probability of error, if there is a probability of error. So, if we choose m1 if P of r1 given m1 into P of m1 is greater than P of r1 given m0 into P of m0. Okay, or else we will choose m0. And to find out the probability of error, first of all we will find out the probability of everything coming off as correct, and then we will be taking its complement, that is 1 minus P of a correct will give us probability of error. So, what is in this case? Okay, then this particular case the probability of a correct one is P of r0 given m0 into P of m0, that is we are receiving r0 when m0 is sent, and or the other correct thing is receiving receiving r1 when m1 is sent, that is P of r1 given m1 into P of m1, and the probability of that is the probability of a correct answer, and the probability of error will be 1 minus P of correct. Okay, and this one is P of x greater than 0, we will get 1 minus P of x less than or equal to 0. And this is, we know that a duality property of a Fourier transform, that is if x of t is having a Fourier transform of x of omega, and if x of t will have a Fourier transform of 2 pi into x of minus omega. And power, to find out the power, we get r excess of 0. Autocorrelation function of energy signal at origin, that is at tau is equal to 0, is equal to total energy of the signal, which is given as this. Okay, so if it is an energy signal, Rx of 0 will get energy, we will get energy. If it is a power signal, Rx of 0 will get the power. Okay, autocorrelation power, autocorrelation of power signal exhibit conjugate symmetry. Autocorrelation function of power signal at tau is equal to 0 is equal to the power of the signal. It depends upon the signal. Okay, if it is an energy signal, autocorrelation function at tau is equal to 0 will give us energy, and if it is a power signal, autocorrelation function at tau is equal to 0 will give us power. Okay, so and again r12 of tau will give us x1 of omega into x2 star of omega. Okay, and we will come to the definition of a variance. It measures how far each number of the set is from the mean, and therefore from every other number in the set. Okay, that is what is meant by variance. Okay, that is a definition of a variance. So, how far each number of the set is different from the mean. Okay, and that is the average degree to which each number is different from the mean. And what is standard deviation? Looks at how far from the mean a group of a number is by using the, it is found out by using the square root of a variance. Okay, and now what is a covariance? Covariance, the formula for covariance is E of x comma y minus E of x into E of y. We have noted it, E of x into E of y. Okay, where it is uncorrelated, then covariance will be equal to 0. And now we will come to what is okay, a definition of a covariance, a measure of a directional relationship between two random variables. That is a measure of how two random variables will be changing when they are compared to each other. That is, if it is a positive correlation covariance, then it means that if one increases, other will increase also. If it is a negative covariance, it means that if one increases, other will decrease. Okay, so that is known as covariance. And with that, I am going to end this video. This PDF will be available in the Telegram group, and if you want to follow me on Instagram, where I'll be I'll be sharing notes, PDF and updates on my videos and everything like that. You can follow that also. All the informations will be down in the description box below. Please like, share and subscribe to my channel. And after watching this video, please go and do the problems on random signals and noise. I have given the problems on random signals and noise PDF with the solutions. Okay, with the solutions, it is available in the Telegram group as well. So thank you for listening and have a nice day.